talked earlier about all the things that make up Jenkins, all the different pieces. These are kind of the four components. So down here on your left, you can see that we have a set of build agents. In the middle here, we have jobs. Up here is kind of new to Jenkins 2.2, actually new in Jenkins 2.2.4. It's an administrative monitor view. So that's the thing I was telling you earlier that kind of watches your Jenkins cluster and it tells you what's going on and when. Shows that I'm logged in, and we have all of these other screens. So I want to take a look at the Manage Jenkins screen. This is a screen that a lot of people don't see. It does exist and it creates all. It has a lot of information. One of the other big components is this configure system screen. This is where all of your configs go. Anything you change inside of this interface will update a file in the file system somewhere. So Jenkins stores all of its data in XML. Plugins have the ability to alter that behavior, but its default mode is XML. When you're going in and trying to do configuration management with Jenkins, one of the common things to try to do is to manage the XML files directly. You don't want to do that. Jenkins will overwrite anything you put there, especially if you do it while it's running. So I'm actually going to log into this master server just to give an example of exactly what's happening behind the scenes. So right here, we can see that we're in the Jenkins home directory. On this installation's large Jenkins home, we have a jobs directory here. We do an ls, so it's not colorful, so it's not helpful. We have a root C directory here. And inside that root C directory, we have a config.xml. Config.xml is the default descriptor name that Jenkins uses for everything. So we have this job here, and we can go ahead and create a new job just to show. And add a build step. Run it, and yay, we have a running job. Now I mentioned earlier about the red-green and how Jenkins shows everything as a red-green. You may have noticed that when I ran this build, it turned blue. Well, the default installation of Jenkins actually uses blue balls. It doesn't use the red ball. It actually requires a plug-in to actually change your ball from to red. All right. So inside of this jobs directory, we can see that that new job was created there. So if I go into there, new job, config.xml. Oh, no, yeah. Okay. All right, so we look at cat, I don't even know what this is. But we look at the file, and some of those components that I was talking about are going to start showing up here. So you can see that everything is XML. We have a project here at the root, and then we start seeing certain components in here. So those different job components that I was speaking about earlier are all represented in this XML. Implementation detail, like Jenkins uses Xstream to serialize objects from Java into XML files. So what you're going to see in here quite a bit is specific class names. And this is highly useful actually when you're trying to write Ruby code to configure some of these plugins. And the reason for that is it gives you the exact class name that you need to be able to configure. So when you're Googling, looking at the XML file will go a long way to get you where you need to go. So I want to illustrate this a little bit further. I'm going to take this new job that I just created. I'm going to start adding some additional stuff. So let's tell it to start over builds. Let's get the GitHub project. Okay. I'm going to add some parameters. This is where you define all the inputs. One important thing to know about the parameters is that anything you define here will automatically be exported to any running code as environment variables. So if you need to consume anything, environment variables are the recommended way to go. You get that functionality for free. I'm going to add in an SCM. And I probably should point out the difference between the one up there and the one down here. Jenkins is very helpful. It will tell you when something is not working. Perfect. Build triggers. You can also see in the new Jenkins 2.0 world, they also broke down the UI to kind of more represent all the different components that you have in your job. We can also tell it to trigger, say build periodically, say build every minute. And I'm not going to touch this yet. So now if we cut out this config.xml again, we can kind of see that it has grown quite significantly. All of those different components that are in there all tie back to different classes and different plugins. So that the starter builds, as you can see, it's build a starter property. The strategy class with model rotators. So that's an implementation detail in that plugin. Other plugins you can see in here, we can see plugin equals GitHub, and actually the plugin version here. Those environment variables that we find up here all work. I want to show really quick the behavior of automatic environment variables. Build parameters. Now we get a prompt when we actually run this thing. Hello. And let's actually add a failure. So another important thing to know about Jenkins is by default, any of its shell steps that it executes, it wants to look at the return code to determine whether or not the command succeeded. So you can see build went from blue to red. Okay, all basic stuff. One of the other important aspects that I didn't talk about now is how we actually integrate with our agents. So behind the scenes, the Jenkins master is talking to the Jenkins agent. So when I ran my Docker compose, you can see that it created this we have a Docker agent and Docker master. So this window over here is kind of a view into all the agents currently connected and where all the jobs are running. I'm going to show another view, the nodes view. So this is another tab that kind of just gives details about all the agents. Jenkins cares quite a bit about the things that the agents are doing and all the details that it requires to know when it actually is talking to us. So it does things like making sure that the clocks are in sync, checking on their free disk space, their swap space, their temp space. It actually has metrics for response time. So the way that I set this up is for this Jenkins agent to be ephemeral. So if I actually go and do a Docker stop and then kill this agent, you can actually see that this agent just goes away. And that's kind of an important thing because normally that doesn't happen. This is the primary reason for using that plugin, the Swarm plugin. So I'm going to bring it back. And there it goes, and it does the negotiation, it goes back. I'm going to give a quick scaling demo. So imagine we had metrics saying our Jenkins cluster was running very slowly. We need to add some additional components. that compose scale agent equals, say, 3. So it's going to create some more agents. And they're automatically going to show up. Cool. Now the question is, how does all this happen? These agents are all driven by a set of scripts and kind of a set of processes that so I kind of want to show this Docker file to kind of illustrate all the components that's needed to create a Jenkins agent. One of the important things I want to talk about is the lack of the stuff that you're not going to see here. So in order for this Jenkins agent to come in service, literally all we have to do is grab a couple of jars from the internet. The Storm client is the plugin, and then we have another script that I created that will actually go and do the code pieces. So Jenkins has the ability to expose a set of endpoints through its plugin mechanisms. I'm just going to step through this script real quick just to kind of give a brief understanding of what it's doing. So the first thing the script does is it says, wait for the master to become available on port 88. After it becomes available, do a loop on the login page and wait for 200. After that, go into this app directory and then download some of these jars from the master. After it does that, we get into one of our other key points at the top is credentials. So it actually will go and in order to talk to the master, it uses an API token, which is generated on its user screen. So if you go back here, you go to people, we go to admin, which is me, we hit configure, and then we hit show API token. We get an API token here. Jenkins needs this API token in order to be able to connect an agent. So this is how the authentication is working. If you look back at my script, you're going to see here that I'm actually using the Jenkins CLI to retrieve those credentials. So using the Jenkins CLI, you actually have the ability to execute ad hoc Ruby scripts, which is super cool. I'm going to actually go into the agent and show that. Alright, so if we look at this jar, which we can retrieve from the master, we saw that curl here. Any Jenkins agent you find on the internet is going to expose this JNLP jars and this Jenkins CLI. The Jenkins CLI jar is the version that was coded to go with this particular instance of Jenkins. You can use it. Usually it's not required for compatibility. One that is important is this slave.jar though. I probably should make a point to mention terminology that Jenkins had used before the word agent is slave. So you're going to see a lot of inconsistency in the plugin world and the new world as they transition. There was a huge PR that they had out saying, get rid of the word slave, we don't like it. So they made a huge PR, replace it everywhere except all the plugins and some of the core pieces like the loading. So if you see slave or agent, they're interchangeable. The PC term to use today is agent. All right, so I'm going to show exactly what this Jenkins CLI is going to do. Let's make sure that it works first. Cool, it does. That error means it's working. So the Jenkins CLI has the same defaults. It knows to read where it's connected to from an environment variable. So if we know about this ENV, we have a Jenkins URL right there. So we're going to say java-jar, Jenkins CLI-jar-I, and we're actually going to give it a PEM file. So as soon as you do that, Jake is going to say, you didn't give me a command. What do you want to do? And it's going to print out all the things that it can do. One of the cool things about this CLI is that the CLI commands can be enhanced by plugins. So plugins exposes any of their functionality over the CLI, it's immediately available. So one of the important ones I want to show is who am I? It's always a good one to get started. And then another one is Ruby. So you can actually tell it to execute a particular Ruby script, or you can actually open up a Ruby console, which is powerful, but also super dangerous. Ruby credentials.ruby. So I'm gonna just tell it to call this command with this script. So what that did was it went and executed this code snippet directly on the master. This println is also part of it, and it's just printing out the user and token as a string. And I'm using that inside of my script to just say, hey, I need an API token. You might be wondering, like, if you already have an SSH key, why are you doing all this junk? Just use that. Unfortunately, the remoting API does not support authentication using SSH or client certificates or anything else that's cool. So it can only do API tokens. So you have to do workarounds like this. And this is kind of that real world nature that I want to kind of hit upon, is that Jenkins, although it's very mature, it still has a long way to go. And with that long way to go, the only way it gets there is by people going and doing the stuff. I'm going to show some PRs that I have open with some of these plugins that kind of give examples of how they just randomly break stuff and you have to go fix it. Alright, so that's the credential script. After it finds that, get that token, it exports it, and then it calls the Java. You give it a couple of variables. You give it that swarm jar, you give it that slave jar, and you give it the swarm client, and then it will connect. And this is how you form an ad hoc cluster. One of the other features of this plugin is that it can actually do its discovery via UDP broadcast, which will allow you to get rid of that secret exchange, because it will say, hey, I'm over here listening for UDP broadcast. Anything that sends out a request, I will send that in its own individual credentials. That doesn't work in places like AWS, where multicast doesn't work. So you have to do stuff like this, where you're passing in URLs and tokens. Alright. Alright, so I showed that. Let me actually go and talk a little bit about the API. So Jenkins has a model that it uses to kind of define everything. Everything it defines has a set of properties that is serializable. So part of the reason this is important is because every URL that you get in Jenkins will be pointing at some form of model somewhere. So almost anywhere you go inside of Jenkins, you can type /API/XML, and you can get XML representation of whatever you're looking at. So in this case, we're looking at Hudson.model.Hudson, which is the main interface. But where it gets interesting is if we go to a job, we can do the same thing. So we can get the XML definition for this job, and we can also get some key details about that job, like the last build was completed, items like that. You can also get any of the parameter definitions. You can get URLs. You can also go down to a specific build and do that same thing. So that information you just got was about the job itself. This is going to be about the last build that we're in. This is one of those areas where if you're not careful, secrets can certainly leak. Because a lot of people don't know that these endpoints exist. And if you're not protecting your secrets by masking them somehow, or using specific plugins to handle it, you can get in trouble. Alright. So now that I give a brief overview of that, I'm going to jump into the job DSL. Are there any questions about any of that random stuff?
You know, with your the master, you can just like push the API key in like a credential store or something like that, and you can discover it that way.
You certainly can. So one of the things, one of the reasons why I do it this way, by using a pre-shared SSH key, is that every time you spin up a fresh Jenkins instance, it generates a new salt for any secret that it uses. So if you had any API tokens that were there before, they're no longer valid if you have a new salt. The only way to get around that is by backing up like the Jenkins home directory, or you can get around it by managing your API users through the Ruby. I don't do it that way because it hasn't been reliable, but the SSH key way has. Another reason why I'm showing it this way is not every environment is set up in such a way where all of the agents have the same level of connectivity to the same things that the master has. So an example is if you have one master in like a prod account, and then you have like 4 development account, or development stage test account, they're all connecting up to this one master. There's no guarantee they can connect to the same secret store. So it's just something you have to coordinate, but you certainly can work around and figure out ways to make it. The challenge becomes trying to get that secret into those environments with Jenkins living in one place. Without its agents, it really doesn't do anything. It certainly has capabilities, but one of the recommendations is to not have executors on your master, simply because you can do stuff like disabling security. Truth be told, you can do that without executors on your master. It's much easier to do that if your master has executors. So usually your master is executors. Any other questions? Did that answer your question? Perfect. All right. So C jobs, Jenkins job DSL. So we have this job here. I kind of want to show it just disappeared. So I'm going to go and roll my Jenkins server. Jenkins is going. Perfect. So, as you can see, the job is gone now. But the job that's not gone is my root C job. And part of the reason for that is I persisted that in the Jenkins home. But more importantly, this job is defined in code. So even if the code job disappeared, I have a way to programmatically remove that section stored in Git. So I'm actually going to run this job, just to kind of give an example of the job DSL. So the job DSL, all its goal in life is to create your jobs and manage them for you. Perfect use case for it if you have a lot of jobs and do a lot of the same things. It is very good at giving you a new DSL to iterate over that. So we can see here, I just ran that job and created 2 other jobs. Created a Gradle C job and a Docker C job. Kind of like Inception. But as we see here, we have a Docker C that was just created. I'm actually going to show what this job looks like. This is the root C, the one that just created that job. So I have this pointing to GitHub right now. I'm saying pull down the master branch and load this C job script from the file system. Under advanced, I don't know why it's under advanced, they have an additional class path option. So it also has the ability to load Groovy code. So if you want to hit the GitHub APIs directly, you can do that. Instead of like doing exactly what I'm about to show, which is defining a list of repositories in your DSL. So if I open up this C.Groovy, this is what it looks like. So we have a list of jobs, hard-coded, that will come back anytime we run this job. I'm just going to do a quick illustration to show like what it would take to add in a whole new set of jobs. Actually, I'm going to do that later. We can see we have Gradle and we have Docker, and all it has in here is the ESL bits, which the high level for the job ESL is the job, which will by default create a freestyle job, and then you give it a name, and then you give it a configuration. In this case, I'm saying create me a job that is pointing to Git using these details, and in that job, I want it to process job DSLs. So these steps are analogous to the builders that I was talking about earlier. All right. So now we saw that. I'm going to go back to this Docker job, Docker seed. Let's run this one. See what happens. Hopefully it doesn't fit. All right. Cool. So this Docker job just ran and it created 3 more jobs. So we have repo 1 master, repo 2 master, repo 3 master. And the way that I define this docker.groovy is by setting up a class for it. So if we go to this class, we will kind of see what the details look like. And I have the reference links to all this stuff. I'm going to push all this stuff up to GitHub so you don't have to consume it all now. Like I said earlier, I just want you to get the core concepts and move forward with that. So inside of here, we can kind of see that we have this build method, and we can kind of start seeing the components that we brought together. So we have a folder that we created called Docker. Inside of Docker, we created another folder, and then after that, we actually created a job. So we have this DSL factory.pipeline job, talking about job types a little bit. Pipeline jobs are the new Ruby-based DSL ones. Freestyle jobs are the one that you're probably more accustomed to. And inside of here, this definition is all specific to the way that the pipeline plugin is set up and defined. I actually want to show the API paths for it. I'll show that in a little bit. But inside of here, we see we have a script. We put this pipeline code in there. This pipeline code is just another Ruby script. I'm going to break down exactly what this script is doing in a second. So we created those 3 jobs. We're here. Let's go to repo 1 master. I'm going to build this job. All right. So the new pipeline DSL goodness. So it gives you a pretty view and the capability of splitting all your jobs into stages. Each one of your stages has a set of logs associated with it. So for this particular build, all I did was check out a Docker file, do a Docker build on it, and then I ran a command to sort of test to make sure that it was working. So inside of here, I'm going to show the pipeline code. And actually, let's just go to configure.
Big question for you.
Yes.
So I noticed you use the jobs DSL to create the pipeline build. I know you can like load external scripts. Like, would you recommend like one approach versus the other there? Because you can kind of like load it into a repo and get like other scripts that kind of define your jobs for your pipeline stages and stuff.
Are you talking about the CPS global library stuff?
Yeah, you could like load it into an external Ruby file and define your pipeline stages that way as opposed to having these jobs.
So the question is surrounding doing it this way versus the new pipeline way. So the pipeline way, just to talk about it briefly, is very similar to Travis CI or Drone. as far as this definition. So the way it works is you drop a file in your repo, it will define all your steps, and then you can actually build, you can actually just have Jenkins scan your organization, look for those Jenkins files, and actually construct all of your builds that way. Is that what you're talking about? Just to make sure.
Yeah, and if you're gonna get to it, I was just kind of curious because you can like load external Ruby files and help define your pipeline stages.
Yeah, and that's exactly what this is doing as well. Some of the pieces are kind of hard to see, but all of these scripts are coming from like another Git repository. So the C job that I showed, it was just loading a Groovy file from another, from its GitHub repository and executing it. To talk briefly about why I haven't jumped on Jenkins files yet, it's simply because the amount of code reuse is very limited with it. So that you have a mechanism for that, the CPS global library, but it's very limited in what it can do. And the way that you have to share them and the permissions that you need to actually use those scripts kind of exceed a level that I was comfortable with. So to use a shared script, you need to run script permission, which pretty much gives you the ability to do it. So you need trusted people making those shared libraries. And this way, I don't have to use any Jenkins files, and I don't have to modify my repositories. And I can just add a list of repositories and just have it scanned. I can also do some of the same functionality that the pipeline plugin, the GitHub branch source plugin does, scanning repositories and creating a list of jobs from there. So the future is certainly using Jenkins files everywhere. I just don't think they're there yet. And one thing I forgot to mention about this job as well is that there are serious compatibility problems with existing plugins using pipeline jobs. And the way that you usually work around that is by wrapping it in a pre-cal job. So this is that script that the pipeline is executed. Just go line by line, since it's a pretty simple script. This node will actually go and allocate an agent and a workspace with this label. This checkout command here is what's actually going to do in the checkout from SCM. Then the stage just creates that pretty view that you saw. Then we do this docker.build. Then we create another stage. And finally, we go and we